Hello everyone, hope you're fine today, and our part of the electricity unit is going to be about studying the RLC circuit, experimental and theoretical analysis of an AC circuit. We have this RLC circuit such that we have a resistor of resistance R, an inductor of inductance L, and a capacitor of capacitance C, having U of R, U of L, U of C respectively. In this case, we have the I is equal, this is I of t, of course, a function of t, I of m sine omega t, and the voltage U of t is um sine omega t plus or minus phi. Plus or minus phi, that's new to us. What do we mean by plus or minus phi? It is the algebraic value of phi. So in an RLC circuit, phi may be 0, or maybe positive or negative, so we call it an algebraic value, maybe positive or negative. In the first scenario for an RLC circuit, it may act like a purely resistive circuit such that I is in phase with U, and this means that at 0 U and I meet. At maximum they meet at the same time as well, and at 0 at the same time, at absolute minimum they meet at the same time, at 0, etc. That's the first scenario of the RLC circuit, may be a resistive circuit. And in this case, phi will be 0. The second case, RLC may be or may act like a capacitive circuit, RC circuit, such that I leads U. This red curve represents U of R and this blue represents U of C. So the maximum value of U of R reaches before the maximum value of U of C. So the maximum of U of R here is leading U of C, but because U of R is the image of I, this means that I leads U by phi. What is the third scenario of an RLC circuit? It may be inductive. In this case, if it's having an inductive circuit, this means that U of L leads U of R, and because U of R is the image of I, this means that U of L leads I, so U leads I. In other words, we can use this one. In the RL circuit, we have used Eli, where U leads I. In the RC circuit, we have used ICE, where I leads U by phi. And now we have RLC circuit, so we have L psi. So if RLC circuit behaves like an inductive circuit, this means U leads I, so U leads I by phi. If the RLC circuit behaves like an RC circuit, then I leads U, or U lags I. Actually, we also need to determine or to find phi experimentally from the graphs. So the equation is 2 pi x from 1 to 2. What do we mean by 1 to 2? It is the maximum point of the first curve to the maximum point of the second curve, such that this point is consecutive to this point. So that's actually a number of divisions we need to find, and this is not up to scale. And then we need to find the t divisions. What do we mean by t divisions? We can choose one of the two curves. So let's choose, for example, the blue one. The blue one we have maximum, but we don't have another maximum. So let's choose the 0 here to 0. So the number of divisions, we just count them. Or we can choose the red from the maximum here to the maximum here. It will be the same number of divisions, and calculate them. How to find U of M? It is SV times Ym. It is the vertical sensitivity, volts per division, and Ym is the maximum height or the maximum amplitude of the curve. Now let's go for the theoretical analysis in order to determine phi and U maximum. Using the addition of voltages is so necessary in this case. U of t is U of r plus U of L plus U of c, and U of r is Ri, but I is the function of t. I am sine omega t, so Ri am sine omega t plus Li m omega cosine omega t plus Q over m using this one. But however, we don't know Q of m, so this means that U of t is given um sine omega t plus or minus phi is equal to this equation, same one, and this one. However, how can we find this? Using I is dq m over dt, and dq is equal I dt, so we have derivative both sides, integrate both sides, integral of q0 to q dqm equal integral I0 to I dt. So, but we have qm is cu of c. We substitute q of m instead of it, cu of c, and c gets out, and we will get this equation. So cross multiplication, du of c is 1 over c I dt. Having derivative both sides, we make antiderivative both sides such that we get the integral of from 0 to u of c of du of c, and equal to 1 over c integral from 0 to ti of t, and we substitute in terms of I its equation. Its equation actually, which we have up, is I am sine omega t times dt. Now substitute in the main equation, we will get um sine omega t plus or minus phi is equal to the same equation, but here the integral of I am sine omega t dt, it is minus cosine omega t divided by omega, divided by the derivative of the inside. Okay, so we will have minus I am over c omega cosine omega t, because the derivative of cosine is minus sine. Minus times minus is plus, and the derivative of cosine omega t, the inside of it is omega, so omega over omega, so it will remain the same as its primitive. Based on that, that's the equation we need to work on. However, we realize that cosine omega t and cosine omega t are common, and I am are common as well. So we take I am cosine omega t as common. What remains inside is L omega minus 1 over c omega. To determine phi, use the particular values. So omega t is equal to phi, so this implies that when omega t is 0, 0 plus or minus phi is 0, so plus or minus phi. So we take it as absolute value, okay, just to facilitate our work, knowing that phi may be positive or negative, and sine 0 is 0. So this term will be cancelled out. Cosine 0 is 1. So what remains is this factor. So that's the first equation. The second equation, it's that omega t is pi over 2. So pi over 2 plus or minus phi, it is in the second quadrant. So because it is pi by 2, it will change to be cosine, and it is positive. So it will be actually cosine phi is equal pi by 2 here. Sine pi by 2 is 1, so RIM. Cosine pi by 2 is 0, so all this will cancel out. The second term will be cancelled out, so only we'll have this equation. Based on that, we know that if we divide the left part of this first equation by the left part of the second equation is equal to the right part of the first equation over the right part of the second equation, we will get this one. However, what's interesting here is that u of m will cancel out and im will cancel out. So this is very interesting because sine over cosine phi is tangent. But what's interesting here is that the tangent is independent of the voltage and the current. It only depends on the inductance, proper frequency, 2 pi f, which is omega, the capacitance, and the resistance. So we'll get tangent phi is L omega minus 1 over c omega all over R equivalent of the circuit. Now let's go for finding the u of m. So we square and add the equations. So um squared sine squared of phi plus u squared m cosine squared phi is equal to im squared L omega minus 1 over c omega all squared plus r squared im squared. That's actually very interesting. Okay, and we can go and have a common denominator Im squared. What remains inside is r squared plus into L omega minus 1 over C omega all squared. Based on that, we need to find u of m. U squared of m into sine squared phi plus cosine squared phi is 1. So what remains is u squared m. Simplifying, we find u of m is Im because it is multiplied here. Okay, and square root of everything inside. What is actually significant is that L omega, we call it the inductance reactance. We'll call it XL. And 1 over C omega, we'll call it the capacitive reactance, which is X of C, which is 1 over C omega, or you just keep it like this. It's true and right as well. Now, for the revision practice exercises, please solve the following 1, 2, and 3 exercises. A potential difference, that's the given, is applied on a non-resistive coil of inductance. We have the value. Determine the maximum current, determine phi, and write the new equation of U. The second exercise practice, exercise I equal 3 square root of 2 sine 100 pi t is applied only on an RC branch such that we have the resistance, we have the capacitance. We need to determine the maximum current, the phi, and determine the new equation of this current. The third practice exercise, resolve the experiment of the book, page 188, section 10.6 RLC circuit, and may you have a blessed day. Enjoy physics.